Welcome to Django REST Framework. My name is Chris, and I will be your guide. In this course, you will learn what is REST and how to use it, how to get started with the Django REST Framework, or DRF as it's known to its friends, and details on the various parts of the DRF, such as serializers, views, view sets, routers, permissions, and actions. A little bit of housekeeping before I get started. First off, this course assumes you are familiar with Django already. You will need to understand Django's models, views, URLs, and a little bit of administration files. If you're new to Django, you might want to check out other courses first. Some links to try are in the description below. Additionally, I'll be using the command line tool curl to visit certain URLs during demonstrations. If you're following along on the command line, you'll need curl installed. Depending on what operating system you're running, you may or may not have it already. If it isn't installed by default, you can get it at the URL here. The code samples shown inside of this course were tested with Python 3.9, Django 3.1.2, and Django REST Framework 3.12.1. There isn't anything that I'm doing here that is particularly version dependent, but if you run into some little weird corner case, that might be why. One final note, as part of our process at RealPython, all the code here has been formatted with black. The reason I bring this up is because the default code generated by Django's admin command is not black compliant. So if you're comparing what you're seeing on my screen with your own settings file, you may notice some presentation differences, and that's because black has changed it. The Django REST framework is, of course, all about REST. REST is a protocol used to send data back and forth between servers. It's the standard that isn't a standard. You can think of it as a protocol guideline, a set of ideas that are commonly used across a lot of interfaces, but not as codified as something like SOAP. REST is built on top of existing HTTP methods and URLs, and this is how you can be a standard without being a standard. The underlying concepts in it are standards. The HTTP methods are used to do things like list available objects, get details on an object, create an object, update an object, patch an object. The difference between updating and patching is whether or not you have to provide all of the fields for an object, and finally, deleting an object. The format of the data sent back and forth in the body of the REST command is up to the implementer. The most common mechanisms for serializing data are JSON and XML. The Django REST framework is a Django library that takes the concepts in REST and ties them to the models and views inside of Django. For each of the major concepts inside of Django, like views, models, and URLs, the DRF provides REST variants on these. First off, Django models get paired with DRF serializers. The serializers specify how to turn the content of a Django model into JSON or XML to be sent to a client. DRF views and view sets are specialized Django views used to control what REST protocol mechanisms are exposed through your API. Like Django URLs, DRF routers map the views to the actual URLs exposed. Out of the box, DRF supports a variety of data rendering interfaces, the most popular being JSON. Other mechanisms are also supported, as well as there being third-party libraries. In addition to regular data like JSON, DRF also comes with a handy web tool that can be useful when you're debugging. All of this is tied together with a handy permission structure to make sure that you're only exposing the data that you mean to. In the next lesson, I'll give you an overview of REST in order to help you get started. In the previous lesson, I gave you an overview of the course. In this lesson, I'm going to introduce you to the concepts behind REST. REST stands for Representational State Transfer. I promise that's probably the only time you will hear that. It comes out of a PhD dissertation by Roy Fielding from just over 20 years ago. Dr. Fielding defined the REST protocol based on the HTTP standard at the time, making it something that could be implemented without making changes to the network. Anyone who could run a web server could run the REST protocol. Not surprisingly for a PhD dissertation, It reads a bit like a PhD dissertation. It contains 6 architectural constraints that define the protocol. The first is client-server architecture. This is the idea that there's a separation between the UI and the data storage and processing. As HTTP is already client-server, this fits nicely. The second constraint is statelessness. No client context is stored on the server between calls. The client has the only context. Any call should be repeatable on the server. HTTP is already this way. In fact, cookies were created inside of the HTTP protocol to get around this fact. The third constraint is cacheability. The protocol needs to be able to support caching on the client side. Once again, this maps very nicely to web servers. Web servers already introduce cache headers to indicate whether or not data has changed on the server side. The system must be layered. This means that things like proxies and load balancers could be between the client and the server and should not affect the client or the calls. The fifth constraint is the ability to have code on demand. I've never actually seen this one used with REST, but it is possible. This is similar to the idea of having HTML and JavaScript come down with a web page, both data, UI, and code in that case. The sixth constraint, a uniform interface, breaks down into 4 properties. The first is resources are identified as requests. Essentially, URLs are what specify the data. The uniqueness of the URL specifies the uniqueness of an item of data. Secondly, resource manipulation through representation. Data itself has enough info to modify or delete the data. The data is self-contained. This is usually implemented through the use of URLs. So the data corresponds to a URL, and you can use that URL to do things like change the data or delete the data on the server side. The data is intended to be self-descriptive. If there's information that is needed about the encoding of the message, it is included in the message. This is similar to the accepted types header inside of HTTP, which indicates what kind of encoding the client supports. And finally, the rather dubious acronym HATES. Hypermedia as the engine of application state. This means links are how you do things. Data should contain links that specify how to manipulate that data. This aspect is one of those that's often ignored. I've seen plenty of REST-like protocols that only use ID numbers inside of the data rather than full URLs. But there is an advantage to embedding the URL. It makes it very simple to go back to the server and get more information simply by using the associated URL. In the overview, I mentioned that REST is the protocol that isn't quite a standard. The code is more what you'd call guidelines than actual rules. I really probably should have done that in my best pirate voice. R. In practice, what this means is every implementation is a little bit different. Oftentimes, only a subset of REST is implemented. When I first started writing REST interfaces, I very seldom implemented the entire protocol. Frequently, I was just doing XML over HTTP, using GET to get the data, which is REST-like, but not bothering with all the puts and patches and other things. For example, using POST to make changes, which isn't quite REST compliant. This lack of adherence to a standard sounds like it might be a problem. How are you going to know what to do? Because the protocol is based on top of HTTP, you don't need any fancy libraries in order to access it. Any library that supports HTTP supports the use of REST. As a result, client-specific code ends up being just that, client-specific code. So whether or not the implementer used POST correctly isn't going to matter very much because you're going to have to look up the API's documentation as to how to talk to it anyways. This allows a rather lazy approach to your coding, in the fact that the clients only have to implement the minimum necessary to access your API and nothing more. The good news about this is it makes REST far more lightweight than similar technologies that are all-encompassing like SOAP. The bad news about this is sometimes you have to pay a little more attention to the documentation to know how you're going to use it. You can get away with this being so ill-defined because REST is built on top of well-known standards like HTTP. If you've done any web programming, you're probably already familiar with the idea of HTTP GET and POST. REST uses these as well as other HTTP methods. Let me run through the different kinds. As I mentioned, GET. The most common one, this is what happens when your browser goes and fetches a web page. It's getting the web page over HTTP. The get method inside of REST is used to either get a single resource with a fully qualified URL, usually including an identifier, or to get a listing of resources. Post is used to create a resource. In the web world, post is used for submitting forms. The body of the post contains the fields of the form. In the REST world, the post is used to create a new object. Those same fields are used to specify the fields of the object that's being created. The URL that you're posting to specifies what object is being created. Put is somewhat like post. It uses the fields to specify information about the object, but in this case, it's to update the object. Patch also is used to update the object. The difference between put and patch is that put requires you to specify all of the fields and replaces them in the object. Patch allows you to specify only a subset of fields and only changes those fields that are given. And finally, delete, obviously enough, deletes the object on the server side. Let me run you through some examples. Here's a URL that if you call the get method on, will retrieve a list of books. Further refining the URL to specify an ID and doing a get will not get all of the books, but a specific book, in this case, the book with ID 12. Posting to the books URL will create a new book. The body of the post contains fields title and author to specify the title and author of the book that is created. Typically, the REST protocol will return the object that was created with its ID information. Post goes just to books. Put goes to a specific book, in this case, book number 23, the book that was created in my last example. Similar to post, you specify fields, the title and the author. In this example, the title is the same as that which was created in the previous one, but the author's been changed. Because it's a put, I have to specify all of the fields. Here's a patch on the same thing. Put requires all of the fields. Patch only requires the fields that I'm changing. So again, I'm specifying book 23, but this time only specifying the title. The author will stay Franz Kafka, and the title will change from Metamorphosis to The Metamorphosis. And finally, here's a delete. Similar to a get, it specifies a URL that fully qualifies the book. In this case, I'm deleting book number 12. The REST protocol does not specify the format of the payload. The most common payloads are JSON and XML. The DRF, which the rest of this course is about, supports these out of the box, and there are third-party packages that you can use to add on to the DRF to support other ones as well. A popular one adds YAML as a payload. Let me show you an example of what a JSON payload looks like. Here, I'm using the curl command to fetch a list of books. The -s parameter specifies silence. This stops curl from showing the progress information. The URL that I'm hitting is the local host on port 8000, for example, on my own little Django server, and the path I'm hitting in the URL is books, because I want a list of books. Normally what comes back from the server is an undifferentiated JSON blob. That tends to be hard to read because it's all in the same line, so I'm going to augment this command with a pretty printer. There are a whole bunch of different programs you can use to pretty print JSON, but seeing this is a Python course, I'm pretty sure you've got Python installed. You can use Python's JSON module directly to pretty print. Calling python-m here specifies to run the JSON tool module. The JSON tool module will take whatever's passed in on standard in this case from the pipe, will pretty print it, and put it to standard out, the screen. So I run the command and I get the following result. Here's some pretty printed JSON, which includes a dictionary. The dictionary has one attribute, which is books. The books attribute is an array that contains two books, the Metamorphosis and the Stranger. Obviously, I was in a bit of an existential mood when I wrote this. That's the basics of REST. Next up, I'll dive into what you're actually here for, the Django REST framework. In the previous lesson, I gave you an overview of REST. In this lesson, I'll give you an introduction to the Django REST framework, concentrating on the serialization and view mechanisms. The Django REST framework is a toolkit for developing web APIs built on top of the Django platform. It integrates with Django models, views, and URL patterns. It provides classes called serializers for turning your Django models into JSON or XML or whatever else you're going to use for your payload, views for controlling what can and can't be seen in your API, and tools to tie into the URLs to specify where your objects live and how to access them. Are you like me and prefer function-based views over class-based views? Or are you one of those folks who are the other way around? No worries, DRF provides a way to handle either case. The serialization toolkits inside of the DRF are most powerful when paired with Django models, but they don't have to be tied to a Django model. You can also serialize non-ORM-based data. And to assist with your debugging, one of the payloads is a web-based interface. You can use the web to interact with the API, examine the payloads that come back, and initiate the different HTTP calls to manipulate objects on the server. Full documentation and tutorials can be found at djangorestframework.org. Not surprisingly, the Django REST framework is built on top of Django, so you'll need both Django and the Django REST framework installed to be able to follow along with this course. As is best practice in the Python world, it's better if you do this inside of a virtual environment. Here's the pip command to install both Django and the Django REST framework. Note that Django REST framework is all one word. Most Django pip modules usually have underscores in them. For some reason, the DRF folks decided not to follow this convention. If you run this command, you'll get a long list of output as Django, DRF, and all of their dependencies gets installed. I'll be using the command line tool curl to show you some of the results coming out of the DRF. Curl comes built in with most operating systems, but in case it doesn't come with yours, you can get it at curl.hacks.se. Don't forget that all the code that I show you inside of this course is available in the supporting material dropdown. It can save you a fair amount of typing if you just grab that zip file and follow along. I'm going to start by setting up a sample Django project, which I'll then use to demonstrate the DRF. First off, I'm going to use the Django command to start a new project called Fedora. Go into the Fedora directory, and you'll see the clean installation of the Fedora directory with settings and URLs, etc., as well as the manage.py command. Next thing that I want to do is create a super user. Before I do that, I need to deal with the database so that the auth tables are built. So I'm going to run migrate. And now that that is done, I'm going to create a super user. Because this is just for me, I'm going to cheat on the password so that I don't have to type anything complicated in. And so Django warns me. Now that I've got the application and the super user, I'm going to create an app inside of Fedora called People. Here's what the directory looks like now. I've got the Fedora directory, I've got a database, I've still got the manage.py, and the newly created People app. Now that I have the project created and the People app created, I need to update the Fedora settings.py file to make a couple small changes. I'm not showing you the entire settings file here, just the sections that I need to change. First off, I'm going to modify the allowed hosts listing to include local hosts so that I can hit it from my browser when I'm using the Django development server. Adding both versions of localhost. And secondly, I need to register the two apps. I need to register Django REST Framework and the newly created People app. First, the Django REST Framework, which oddly enough has the underscore in it, even though the PyPI module doesn't, and the newly created People app. That's all the changes for the settings file. Now that everything's set up, let's start writing some code. First off, I'm going to create a person object for the database using a Django model. I'm going to keep the model fairly simple here with 3 fields: first name, last name, and title. And then, because I'm anal retentive and I don't like persons showing up in the Django admin, I'm going to update the meta value to people. Here's the first bit of DRF code. Create a file called serializers.py inside of the People app. This file is the pair of the model. Typically what happens is with every model you create, you also create a serializer. The serializer specifies how to turn the model into the payload data for REST. By convention, the serializers are named the same thing as the models. So here on line 5, you see me declare person serializer to serialize my person object from the models file. Similar to how a person inherits from model, the serializer inherits from the model serializer. Model serializers do a whole bunch of work for you. They automatically look at the model that's associated with them and know how to serialize the different kinds of fields. There's all sorts of control you can do here to get fancy, and I'll show you that in later lessons. But for now, all I want to do is serialize the model as it is. I have to do two things inside of the meta section. Specify the model this is associated with, which in this case is person, and the fields that I am going to serialize: ID, first, last, and title. And that's all I need to do. Serialization's now ready to go. The DRF will take care of the rest of turning the model into a payload. Serializers themselves are only responsible for turning models into payloads. They don't actually create the views or map to the URLs. The DRF uses the same kind of patterns as Django. So now I'm editing the people views file, and I'm going to create a new view. This is on line 9, list people. What this is going to do is list all of the people in the database, serialize each one of them, and return a payload with a listing of all of the people. Line 8 is a decorator from DRF that tells DRF that this is going to be associated with the HTTP GET method. DRF supports all of the HTTP methods supported by REST, so I can create views using the API view decorator tied to any one of those HTTP methods. Notice that it takes a list. You can actually have it associated with multiple HTTP methods if you desire. On line 10, I get a query set of all of my people. On line 11, I instantiate the person serializer defined in the previous file, passing in the query set and the variable many set to true. The serializer is capable of serializing more than one object at a time. By passing in the entire people query set with all the people objects in it and many equals true, I will get all the data serialized for every one of the people in the query set. Similar to an HTTP response object, DRF has its own response object. It takes a content dictionary. In this case, I'm defining the content to have a single key named people and the data associated with the serializer. Creating the payload is a two-step process. The first step is instantiating a serializer with your query set, and the second step is referencing the data property and putting it into the response object. The view I've just shown you is a Django view like any other, and as such, I need to register it inside of the URLs file. I'm going to do this by creating a URLs file inside of people, and I'm going to specify a path called list people, associating that with the view that I just created. You're going to need something to serialize, of course, otherwise your payload will just be empty. In order to make that easy, I've created a person admin object with the first, last, and title fields so that I can go into the Django admin and create some data in the database. Okay, I'm almost all set now. The last thing I need to do is just register the people URLs with the global Fedora URLs. There are a couple things I have to do to this file. First off, I have to update line 3 to include the include function, because I'm going to include all of the people URLs. Secondly, I'm going to create a path called people and include all of the people URLs file. Now you'll be able to hit the development server with the path people/list people included from the apps URLs file. Okay, all the code's set up, almost ready to go. I need to register the database changes with the make migrations command. It found people and registered it. Now I need to migrate that. Great, the database is all set up. And in order to be able to demo, I'm going to have to actually have some data in the database. I'm going to run the Django development server and show you the admin right now. Off screen, I'm running the Django development server, And here in my trusty web browser, I'm going to open up the admin URL. That's localhost/admin. I'm going to log in with admin, and the super secret 5-letter password I created earlier begins with A and rhymes with admin. And here I am inside of the Django admin. I'm going to add a few people by clicking on the add button. And here are my 4 people for the database. Or if you don't feel like doing all of that, I managed to save all of that in a fixture for you, so you can run the load data command. Either way, you've now got some data in the database with some people. Running the Django server, and then I'm going to switch to the lower window and hit that server with curl. First off, localhost port 8000 people list people, the view that I just created a few minutes ago. The response that comes back is in JSON. It's a dictionary with the single key people and an array of the 4 people I created in the database. In the upper window, you can see the get that was executed. The URL people list people was hit, and that translated into the list people view that I created in the views.py file in the people app. Because that's a little hard to see, I'm going to do that again for you, but this time in a full window. Here's the curl command. I'm using -s so that I don't get the progress bar as I go along. I'm hitting the same URL, port 8000 on localhost, people list people, and then as I did in the previous lesson, I'm going to pipe this through Python using the JSON tools module to pretty print the result. Let me just scroll up here for you. What comes back is a dictionary with a single attribute of people and the 4 people that I created in the dictionary. That kind of feels like a lot, but most of what I did there was just typical Django stuff. Let me just quickly review what I had to do. First off, I created the project and the app inside the project. Secondly, I created a person model, no different than I would create any model inside of a Django application. The first DRF specific thing I did was create the person serializer, which maps the person model object to a REST payload. I then created a view that uses a DRF response object to send a serialization of the person.objects.all query set down in the payload of REST. And finally, I had to register this view as a URL like any other view in Django. If you're new to Django, there was a lot to follow along there. If Django's old hat for you, there was very little extra code that you had to do to take your typical Django application and make it a REST-capable one. So far, I've shown you the simplest possible view. The view sets mechanism in DRF gives you a lot of power to do a lot of REST stuff with very little code. Next up, I'll introduce you to view sets. In the previous lesson, I talked about the Django REST Framework serialization mechanism and how to use the API view decorator to create a view. In this lesson, I'm going to be drilling down more on views and introducing the DRF view sets class. As a quick refresher, here are the DRF components so far. You've seen the serializer. The serializer is responsible for taking an object and turning it into a text payload, or also to take text payloads and turning them back into objects. Most of the time you're going to want to do this with a Django model, but it doesn't have to be. The entry point for your REST call is a view, just like a regular Django view. The DRF provides decorators to make this a little easier. The heart of it is you have to return a DRF response object with your serialized data inside of it for what to respond to with the view. To make your life easier, the DRF also has a concept called view sets. A view set is a class that encapsulates the common REST HTTP method calls, things like the gets, the posts, the patches, etc. Using a view set makes it far faster to implement a series of REST calls on a class of objects. Going with the view sets is the concept of a router. A router allows you to use a view set to declare a series of URLs. This means you have far less work to do. You just map the view set to a router, and the DRF takes care of the rest of it for you. Here's an example base view set taken straight out of the DRF docs. As you can see, it declares 6 methods on the view set class: list, create, retrieve, update, partial update, and destroy. List maps to the get method for listing the objects. This would be used to do something similar to the people list view that I showed you in the previous lesson. Create maps to the post, allowing you to create a new object. Retrieve maps to the get, but for a specific identifier, so to get book number 12. Update maps to HTTP put, taking an object as well as some fields, those fields updating the values inside of the object specified. Partial update maps to patch, taking an object as well as a subset of fields, only updating those fields that are given. And destroy maps to the HTTP delete method. Throughout this course, I'm going to continue building on the Fedora project. For the most part, I'm going to create a new app for each lesson. I won't stepwise go through the process of creating each app. I will just quickly summarize it in order to save time. If you need guidance on how to do this, see the previous lesson or dig into one of the other Django courses. To get going for this lesson, I'm going to create another app, this one called Artifacts. I'm going to have to edit the settings.py file, adding artifacts to the installed apps list. I'm going to have to edit the Fedora URLs file to add the artifacts URLs file in the URLs pattern list. And then for the rest of this lesson, I'm going to show you the contents of models.py, serializers.py, views.py, and URLs.py. You can code along with me as I go. In order to play with the REST interface, you're going to need some data. So you can either create an admin.py file to go with the models.py, or you can use the one supplied in the supplemental materials. Don't forget to run make migrations and migrate as necessary, and then use the admin or load data command to add some data to play with. Inside of your newly created Artifacts app, edit the models.py file and add this code. What I've done here is created a new Django model called Artifact. It has 2 fields, a character field for name and a Boolean field to indicate whether or not the artifact is shiny. Like before, I need a serializer. Inside of a new file called serializers.py, I'm creating the artifact serializer. As in the previous lesson, all I need to do here is identify the model that's being serialized, which in this case is the artifact, and the list of fields that I want serialized. The DRF provides a handy shortcut. Instead of fields being a list, you can give it the string dunder all, and all the fields in the artifact will be serialized. The DRF is all about making your life easier and writing less code. Instead of writing a view, this time I'm going to write a view set. A view set is a view class, and to keep things short and sweet, all you have to do is provide the serializer that you want associated with the view set and the query set associated with that serializer, and the DRF will create everything else for you. So on line 7, by convention, I name it the artifact view set. You'll notice this pattern seems to hold. Artifact serializer goes with our artifact model. This inherits from the model view set class. On line 8, I specify the serializer class, which is the artifact serializer. And on line 10 and 11, I override the getQuerySet method, returning the query set of what I want. In this case, it's all of the artifact objects. Essentially, I'm accomplishing the same kind of thing that I did with the people list in the previous lesson. I'm listing off all of the artifacts, but this time, because I'm implementing the model view set, not only am I getting the get for the listing, I'm also provided with retrieves, deletes, creates, and both kinds of updates. To wire this view set into the system, I use a router. Inside of artifacts URLs.py, on line 7, I create a default router, and on line 8, I register this router. I'm registering the artifact view set under the name artifacts. This means it'll be listed under the path artifacts wherever my URL is mounted. By using this router, I don't have to specify routes for all the different URLs for creates and posts and patches. I just have to register the router, and then on line 11, include that router. In a separate window, I'm running the Django development server. Now I'm going to demonstrate hitting those REST URLs with curl. First off, a simple get. I'm hitting localhost port 8000 under artifacts and piping it through JSON tools to get a pretty print. And what I get back is a dictionary with artifacts and a URL that says go to artifacts/artifacts. This happens because of the way I set up the router. The first artifacts in that URL is part of the path from my include. The second artifacts in that URL is placed there from the registration of the router. In later lessons, after you've registered a bunch of different routers, this listing will be helpful. It gives the developer information about all the possible object routers that are available. Right now it seems a little redundant because there's only one thing in there. But I'll take the hint, I'll use that dictionary and get that first URL. Once again with curl, piping it through the JSON tool, and there you go. This is the get for the artifacts/artifacts path. It returns 2 artifacts from the database. Notice it's just a list in this case. There's no dictionary to go with it. I can also do a get on a specific value from the database by appending the ID of the object to the previous URL. Still a get. Same localhost, same port, this time with ID 1. And what is returned is just the information about that specific object. So far, so good. Now let's do a create. The -X parameter to curl tells it to use a different kind of HTTP method, and -D are fields to pass in. In this case, I'm passing in the name and shiny fields. It hits the URL. It's a bit of a long command line there, so notice that it's wrapped around to the second line. And what comes back is JSON of the new item created, the Ark of the Covenant, with shiny, of course, being true. This time I didn't pass it through the pretty printer, so it just gets spit out all in one line. If I run the listing again, you'll notice that the Ark of the Covenant has been added to our list of artifacts. Now let's do an update. Once again using the -X, this time using the HTTP put method, specifying fields for golden idol and shiny true, and the full URL of the object that I'm replacing, object 1. This renames the Chachapoyan fertility idol to the easier to say golden idol. As with the post, what comes back is the object that was changed. Let me try the same thing, but with a subset of the fields, this time only specifying shiny. I get back an error from the server. Notice that this error is similar to how a Django form field works. If you fail to specify a required field in a Django form, Django gives you error information about what field failed. Django REST framework is doing the same thing here. Because I used a put, and a put maps to an update, you have to provide all fields for an update, and because I failed to provide the name field, I get back a dictionary with an error that says the name is required. If I only want to update the single field, instead of using a put, I have to use a patch. Similar concept here, this time using HTTP patch, provide only the shiny field, and same URL. And this time it worked. I don't know what Balak did to that pretty little gold statue to make it no longer shiny, but the database reflects it now. The only HTTP method left is delete, so here it goes. Once again, -X, this time with delete. Specify a URL that has a specific object. In this case, you get nothing back from the server. If I run the listing, get again, you'll see that the golden idol is no longer there. I guess Balak took it out of inventory. By using a view set instead of a view, you automatically get the list, retrieve, create, update, partial update, and delete methods for your object. In just a couple lines of code, you've fully defined a REST interface for your object. This is extremely convenient and shows off the power of the DRF. Normally, I'm a views should be functions kind of guy, but when I use the DRF, view sets are the way to go. In addition to the convenience of having the view set define all of those things, the router means you don't have to define the mappings for all of those. List, retrieve, create, update, partial update, and delete are all created by the router in a single line. The DRF saves you an awful lot of work and an awful lot of definition. Everything's about the shortcuts here. So that was view sets. Next up, I'll show you the web interface, a great way to debug your REST application. In the previous lesson, I introduced you to DRF view sets. In this lesson, I'm going to show you the built-in web interface and explain how renderers work. Built into the DRF is a web interface. The same URLs I've been showing you in previous lessons, if you hit those with a web browser instead of something like curl, you'll get a full HTML page, including the payload and the ability to run actions on the objects. How does DRF know what to respond with? Well, there's two answers to that question. First, what renderers are installed? And second, what HTTP accept headers are sent? For example, if you had a YAML and an HTML renderer installed, and your program sent the following accept header, accepting JSON, indented JSON, YAML, HTML, and everything else, then YAML would be used because it's the first renderer that matches that accept string. Up until now, when I've been using curl in the demonstration, curl by default accepts star.star, so it hits the first renderer installed, which by default is the JSON renderer. You can affect what renderers are used by changing a setting in settings.py. Declare the REST Framework Dictionary with a default renderer classes attribute, and that specifies what renderers to use. What's showing here is actually the default. If you don't specify anything in settings.py, this will be what you get. This says to use the JSON renderer and then the web API renderer. As I mentioned, curl accepts everything, and because JSON renderer is declared first, this will be what matches. In a production system, you may not want to use these default renderers. As an example, the web renderer will download all sorts of options for choice fields. So if you have a field with thousands of possible choices available to it, the browser will download this every single time. By making the web renderer available, you are potentially opening yourself up to a denial of service attack. It's very handy to have this renderer when you're debugging, but it's not a bad idea to turn it off once you go into production. The web renderer also makes your API far more discoverable. A lot of information is presented. Now, all of that information is still queryable through other renderers, but it makes it easier to find. Security through obscurity isn't a valid approach, but why make it easy on people? In addition to setting the renderer inside of settings.py at a global level, you can also set it specifically. For example, in a view class, you can use the renderer classes decorator to specify what renderers are valid with a view. This one only supports the JSON renderer. Notice that the parameter to the decorator is a list, so you can specify multiple renderers if you wish. Alternatively, you can also set it inside of a view set. View sets inherit from API view class, and all API view classes support an attribute called renderer classes. This is similar to using the decorator in the previous example, but it sets the renderer for all of the actions associated with this view set. The DRF comes with a bunch of different choices for renderers. You've seen the JSON renderer already. The template HTML renderer uses Django's template engine to render whatever template you pass it. The static HTML renderer takes a string, which is supposed to contain HTML. You still use the DRF response object, but in this case you pass it the string that you want rendered. The browsable API renderer is the web renderer, which I've been talking about and will show you shortly. The admin renderer is similar to the browsable API renderer, but the interface looks like the Django admin instead of the default. The HTML form renderer renders a HTML form object. Typically, this isn't used on its own, but used in conjunction with a template, which is then fetching a form. The forms are then based on the body of the REST elements. The multi-part renderer is another one that isn't used on its own. This is also for forms, but in this case multi-part forms, and typically is only used for testing. In addition to all of those, there are a whole bunch of third-party packages as well, supporting YAML, XML. If you're not happy with the format of the JSON, there's multiple different types of JSON, so you can make it look just about however you like. Message pack, Excel, CSV files, a variety of Panda-based plugins which support CSV, Excel, and PNG, and LaTeX, of all things. The DRF renderer system has been built so that you can customize it and create your own. If you want to look into this, you can look at the API guide in the renderers section. And now let me demo the web interface. In a window off screen, I'm running the Django dev server. I'm going to hit the same artifacts URL that I showed you with curl in the previous lesson. And here's the web interface. The API route view is whatever you defined inside of the default router. At the moment, all I have defined is the artifacts section. Down here in the body of the response, you see the headers that came back, as well as the payload. This is just like the curl view before, but has the added benefit of the link is now clickable. Clicking the link gives me the retrieve method, the list of artifacts, in this case showing the 2 artifacts that are in the database. If I scroll down, there's a form that complies with the artifact serializer. Clicking Post will call the create method in REST. The end result on the screen is the newly created object, with ID3, name, golden idle, and shiny set to true. In the breadcrumbs at the top, I can go back to the artifact list, and now you'll notice I've got 3 objects in the database. I can modify the URL at the top and specify a particular ID doing a retrieve. And here you are back at the detail information for artifact 3. Notice this allow header tells you just what HTTP methods are available for this particular object. Because the artifact view set was default, it supports all of the possible HTTP methods. Scrolling down once again, I can change the form, click on Put, and this will cause an update to happen. Just like before, I've changed the artifact from shiny to not so shiny. Along the top, there's a delete button so that I can call the delete method. It confirms, which I approve, and it tells me that the object has been deleted. Notice that the URL is still for object number 3, but there's no information here because there's no content for object number 3. Clicking back on the artifact list, I'm back to having just the 2 objects. If you're tired of the web interface and want to see exactly what comes back, you can change the format of the GET using this button on the right-hand side. By selecting JSON, the page now comes back as JSON. This particular view is what Firefox does with JSON. Clicking on raw data shows you what actually came back. As you can see, this is a really powerful and useful tool. I use it almost continually whenever I'm trying to debug my REST APIs. That's it for the web interface. Next up, I'll show you how to control access using DRF permissions. In the previous lesson, I showed you the DRF web interface and renderers. In this and the next lesson, I'm going to be talking about the DRF permissions. The Django REST framework has a robust permission mechanism. The most common usage of it is tied to your view sets. You can specify permissions at both the request level and at the object level. An example of request would be whether or not you're logged in. An example of the object is whether or not you are able to look at or change that particular object. In order to demonstrate DRF permissions, I'm going to have to set up a whole bunch of Django auth pieces. I'm going to spend this lesson prepping and the next lesson diving into the actual DRF permissions. If you are very comfortable with Django auth, logins, creating login screens, and creating accounts, you can skip this lesson and not worry about it. If the Django contrib auth module is new to you, then you might want to stick around. Everything that I show you inside of this lesson is moving towards the fact that I need a couple more accounts than just the admin account. I'm going to create an account called Indy that has the staff setting set to true, and another account called Marion that's just general usage. Out of the box, Django no longer comes with a login page. In order to be able to play with this and have accounts log in and log out, I'm going to need to create a login page to go with these accounts. This lesson is going to be just a short review on how these pieces work. If you want to see details on how to use the Django auth library, this article could be of use to you. The first change I want to make isn't really necessary, but it will make your life a little easier. Inside of Fedora settings, you'll find a definition for auth password validators. This specifies what password validators Django runs when you create an account. Because I'm just going to be messing around and I don't want to have to deal with this, I'm going to zero all of this out. This is generally a bad idea. You're breaking built-in security. But, it's just between us friends, so I'm getting rid of that. The second thing I need to do is create a login page. That's going to be rendered as a Django template. In order to do that, I'm going to need a templates directory. So I'm going to make that inside of the Fedora project. The template itself has to go in a directory called registration. So inside of the templates directory, I'm going to create another directory called registration. Once those directories exist, I'm back into Fedora settings, and I need to tell Django to look in those directories for some template content. Look for the templates definition and change the value for the DIRS key. It needs to be changed to point to that template directory. Base dir is defined near the top of the settings file and specifies where the project exists, so templates is relative to that base dir. If you happen to be using an older version of Django, do note that Django 3 uses the path module. This base dir is defined as a path. In Django 2 and before, this would have been an os.path.join call. While I've got settings open, I also want to make one more change. I'm going to tell Django where to go if someone logs in and they aren't explicitly told to go somewhere. So this is the default definition for a logged in user. I'm going to set that to a view called library. Django provides views for doing authentication, but does not include them by default. So I'm updating the Fedora URLs file to include the URLs for those views. They're in the contrib auth module, and I'm going to include them under a path called accounts. Finally, I need the actual template for the login page. I'm going to create the world's simplest login HTML. It's not very pretty, it really just has the form in it, but this will do the job. This HTML code goes inside of a file called login.html inside of that newly created templates/registration directory. The contrib auth module automatically looks for a template with this name, and that's how these pieces are wired together. With all that set up, I'm now ready to use the Django admin to create a couple of accounts. In a window off screen, I'm running the Django development server, and now I'm going to point the browser at localhost/admin. Once again, logging in with my super secret password. And now in order to create two accounts, I'm going to click on the add button for the users. The first account I'm going to create is for Indy. I type in the username and passwords, being grateful that I turned off the validators. And when I hit save, the admin will let me edit this newly created account. Indy was added successfully. I'm going to scroll down to permissions, make Indy staff, and save. And you can see that Indy has been added. Adding one more user, Because I don't need to make any more changes for Marion, I can just scroll down to the bottom and save. As you can see here in the listing, Indy is staff and Marion is not. Great, now that you've got those accounts, you're all set to see how the DRF and permissions actually work, coming up in the next lesson. In the previous lesson, I gave a quick review of the Django authentication module. In this lesson, I'm going to use the accounts created in the previous lesson to show you how DRF permissions work. In case you skipped the previous lesson, I'll just quickly run through what I did. I installed the Django contrib auth module. I added a login page, and I created two accounts, one called Indy with the staff parameter set to true, and one called Marion. Okay, the background's in place now. I've got some accounts so that I can show you who can do what with different permissions. Now I'm going to add another app for books. This will be where I demonstrate the permissions. If you're writing the code yourself while you're following along, you're going to need to change the settings file to add books to the installed apps, change the URLs file to include books.urls, and then create the files that I'm going to show you for your models, serializers, views, and URLs. Like before, you'll need to create your own admin file or pick one from the supplementing materials if you wish to use the admin to create your data. You'll need to run make migrations and migrate as necessary on the models, and then use the admin or a load data command to get data in so that you can play with the REST content. Here's the model file for my newly created Books app. I'm creating an ORM class called Book that has two fields, title, the title of the book, and whether or not the book is restricted, which is a Boolean. Similar to the artifacts, I'm going to create a book serializer. It's the minimum possible serializer, taking everything in the book model and serializing it. Inside of the book app's URLs file, I'm going to do two things. First, I'm going to register a router for the book view set, which I'll be defining shortly. That router is defined on line 8 and then included on line 11. And then on line 12, I'm also adding a view, which is the home view for this area. You may recall that inside of the settings file, I set the login redirect to be books/library. Well, there's going to need to be a view there, so I'm setting the path up for that now. And now here's the views file. It's a little longer than things from before. First off, let me scroll down a little bit to show you the home view, the library method. This method's pretty simple. All it does is output some static HTML. This is pretty bad practice. You should be using template files inside of Django, but it's easier to just show it to you this way. What this home page will do is show you who is logged in, provide a link to the REST API, and a link for logging out. All of that will be rather useful when I try to demo this shortly. Secondly, I'm setting up a book view set. The only difference between this and the artifacts view set is the newly added permission classes attribute. Permission classes takes a list. In this case, I'm passing in the isAuthenticated class. Let me just scroll up for a second. IsAuthenticated comes from REST Framework permissions. With this permission class in place, the book view set will only be visible to people who are authenticated via Django. Here I am back inside of the admin. I'm going to go to the logout link and log out of the account. Now, let me visit the books/library URL. The library page home view requires you to be logged in. As a result, it redirected me to the login page, which I created inside of the templates directory before. Now I'm going to log in as Indy, and here I am at that library homepage. It shows me that I'm logged in as Indy and provides a link to the Books API. Let me visit that. And here's the result, the listing of books. Going back to the library page, logging out, and then going straight to the books listing. And you'll notice what comes back from the REST API is a permission denied. I'm not logged in, so it doesn't let me see the list. So far, so good. Is authenticated stops anyone who isn't authenticated from seeing your REST API. Let's experiment a little bit. I want to change the permission class. Right now, it's is authenticated. Let's change that to something else. Here's is admin user, also part of the DRF permissions library. Going back to the same book's entry point. Still not authenticated. That makes sense because I still haven't logged in. Now, visiting the login page, logging in as admin, and there's my books API. So far, so good. Let me go back, log out. This time I'm going to log in as Indy. Here I am as Indy, visiting the books API. Uh-oh, that's not quite what I had planned. It turns out that DRF's is admin really means is staff. Because the admin account is both a super user and staff, it's allowed in. And because Indy is staff, he's allowed in. If I logged in with Marion, it would forbid me because she's neither. So let's make some changes to the code to fix that. I'm back inside of views.py, and now I'm going to add my own custom permission class. This is called isSuperUser, and it inherits from the base permission class. It has one method, which is hasPermission, and inside of that, I'm going to look at the request object, the user who's associated with the request object, and I'm going to check the isSuperUser property and return that as the value for hasPermission. Now, if the user is a super user, they'll be allowed in, and if they're not, they won't. So in this case, Indy, who's only staff, should be denied. I also have to change the permission class attribute on the book view set. Change that from isAdminUser to my newly created isSuperUser. Here's the web browser again. I'm still logged in as Indy. Going to the Books API, and Indy no longer has permission. That's good. Let me just go back, log out, log in as admin, go to the Books API, and there's the listing. isSuperUser works. You can also chain permissions together. Let's add another custom permission, this time checking whether or not you're Indy. Same as before, inheriting from base permission, but this time I'm going to make a change. I'm going to override the hasObjectPermission method. This allows me to specify permissions at the object level rather than at the global level. What I'm going to do here is check whether or not the object itself, which in this case is a book, is restricted. So this is happening on line 17. If the book does not have the restricted flag, then anyone is able to see this because I'm always returning true. If you get to line 20, the book is restricted, and in this case, it checks whether or not the username is Indy. If it is, Indy's allowed to see the restricted books. Everyone else is not. The other change that I have to make is inside of isSuperUser because I'm going to combine these two permissions. By default, inside of base permission, permission is granted. So if I chain isIndy with isSuperUser and I don't change the hasObjectPermission for isSuperUser, it will always be granted, which is something you have to be very careful with. Personally, if I were designing the framework, I would make permission denied be the default rather than permission accepted. So you have to be very, very cautious when you play with this stuff inside of the DRF. I have already shot myself in the foot several times with this particular feature, accidentally opening up permissions when I didn't mean to. Let me show you the change. Defining hasObjectPermission inside of isSuperUser. And setting the return value the same as hasPermission. So this makes sure that if the permission's being checked at the global level, at the request level, you check whether or not it is SuperUser, as well as at the object level. Finally, I'm going to update the permission classes, and I'm going to change this to chain the permissions together. You do this with the OR operator. Now, when someone visits the view, it checks the isIndy permission. If that passes, they are allowed in. If it does not pass, then the isSuperUser permission is checked. Back at the library homepage here, I'm just going to log out and log in as Indy. Visit the Books API, and you'll notice that everything here is listed. Now I'm going to visit a particular title by changing the URL to look at book number 2, which is a restricted book. You'll notice that Indy can see this. This is the expected behavior. I'm sure you can tell by the way I'm demonstrating this that there's a but coming. Let me log out and show you the problem. Logging in as Marion, visiting the Books API, and there's the problem. Notice that Marion can see everything, including the restricted books. So what happened here? Well, it is actually working. It's just that the listing and editing are different concepts, and the permissions only apply to the editing, not to the listing. The listing is done through a separate mechanism through your query set. To show that this is working, I'm going to visit the specific URL for Tanis and You. And because I'm logged in as Marion, I now get permission denied. So it's working, just not the way you might expect. So you've seen that the permission classes only affects whether or not you can actually touch the object specifically. It doesn't affect the listing. This is a little counterintuitive and unfortunately allows you to accidentally expose things through your API that you may not have intended. In order to have the behavior that I want here so that restricted books don't show up in the listing, I have to modify not just the permission classes, but also the query set. Here's a subset of the views class, just the view set. I'm going to change the query set now to include a filter. Inside of the query set, you can get at the request object, and you can decide who the request is for. In this case, I'm checking whether or not the user is staff. If the user is staff, then all books go back, no matter what, essentially ignoring the restricted field. Otherwise, so users who are not staff or not logged in, you will get a filtered version of the query set, and that filtered only shows the non-restricted books. Still logged in as Marion, clicking on the Books API, and now my book listing no longer has Tanis and You because it's restricted. So you've learned how to use permissions. More importantly, you've learned how to be very careful with permissions. First off, default permissions allow entry rather than deny them. That can be a problem if you mess things up. Secondly, permissions don't apply to filters. So if you want to make sure that only things with permissions show up inside of your listings, you have to do more than just set the permission. You also have to change your query set. There's a lot of power here, and I always hesitate when I criticize somebody who's written open source software because more power to them, we're all using it, and that's fantastic. That being said, you got to be a little careful here, or you'll end up with some toes missing. So that's the permission mechanisms. Next up, I'm going to do a deeper dive on serialization and show you how to do some fancier stuff. In the previous lesson, I showed you how to use permissions with the DRF. In this lesson, I'm going to show you how to use serializers that are not associated with a Django model. Up until now, all of the serialization that I've shown you has been associated with a Django database ORM object. You don't have to do that. You can create a serializer from scratch, and it doesn't have to serialize something from Django. You do this by inheriting from the serializers.serializer class and combine it with serializer fields. Serializer fields are similar to Django model fields. You can explicitly create a serializer specifying field by field. It doesn't have to be based on that ORM. In this lesson and the next lesson, I'm going to use the same app, which is a new one called Vehicles. Like always, if you're coding along with me, you'll need to add vehicles to your installed apps list. You'll need to update your URLs file to include vehicle.urls to pull in anything defined there. And then follow along with any models, serializers, views, and URLs that I show you. For this particular lesson, there won't be anything to migrate. I'm going to create stuff inside of the models space, but it is not going to be Django objects, so you won't have to do the make migration and migrate. Because I'm going to be using the same vehicles app in this lesson and in the next lesson, and I'm going to be creating multiple models, in order to be a little more organized, I'm going to switch over from using a models.py file to a models directory. If you haven't seen this before inside of Django, the mechanism's more or less the same. Instead of creating the models.py file, you create a directory and then create files inside of it. There's one extra step that you have to do to get all this to work, which I'll show you in a second. Inside of the models directory, I've created a file called tools.py, and inside of that, I'm creating a regular old Python object. This object has a couple of attributes, one called name, the other called make, and all I'm doing inside of the initialization is assigning those to the object. So that that file I just created can be read from the models as a module, I've had to create a double underscore init file, and I'm going to import that tool object inside of it. Now for the serializer. In order to keep the code nice and clean, I'm going to use a serializers directory similar to the models directory. And so inside of the serializers directory, I'm going to create tools.py, which corresponds to the tools.py file inside of the models directory. Here's my generic serializer. Notice that it's inheriting from just serializer instead of model serializer. I'm specifying each of the fields that I'm going to serialize, and I specify one field for each of the attributes of the tool object. Both of these are char fields, which, similar to Django model char fields, contain text and have a max length in this case of 50. Continuing on with the pattern, I've created a views directory, and inside of that, I've created tools.py. For tools, I'm creating a single view that just lists the tools to give you the idea of how this serialization works. On line 8, I'm using the API view decorator in the exact same way as one of the early lessons. And line 9, I'm creating the definition of the list tools view. Line 10 through 13, I'm creating two tool objects. These are just generic Python classes that have been instantiated as hammer and wrench. From line 15 on, this method is no different than when it is a Django object being serialized. You create the serializer, you pass in the thing being serialized, in this case a list of the tool objects. Because it's multiple objects, I'm setting many set to true. And then I create a content dictionary that consists of the serialized data and pass it into a REST response object. Finally, to make it accessible, I need to add list tools as a path, pointing it to the view. To demonstrate this view, I'm going to use the browser and point it at the web interface. Going to the list tools view that I just created. And like before, you get back the same kind of interface showing the serialized data. You can serialize anything you like. It doesn't have to be a Django object. This gives you a fair amount of power. You can serialize the things in your database, or if you want, you can create your own as needed by your application. In the sample code, I showed you how to use the char fields. There are a large number of fields provided by the DRF. There are fields for Boolean, a long list of string fields. Most of these are similar. What changes is the validation. So for example, the IP address field is still just a string, but the validator makes sure that the string is formatted as a valid IP address. There are 3 numeric fields, fields for date and time, and 2 fields that allow choices of predetermined selections. There are fields for uploaded files, composite fields which hold groupings of other things like dictionaries or nested JSON, and specialty fields like read-only and hidden for your forms, or the serializer method field, which is a special field that is read-only that gets mapped to a method inside of the serializer. Every time the field is serialized, that method gets called, which allows you to run arbitrary code anytime serialization happens. If all of that's not enough, you can always write your own. But before you do, you should check out whether or not what you are trying to dream up has already been done for you by someone else. There are plenty of third-party libraries out there that contain other kinds of fields that you might find useful. When you instantiate a field, you can pass it arguments to control how it behaves. Some of the arguments are whether or not the field is read-only, write-only, required, what its default value is, whether it allows null, what the source attribute of the field is. By default, the serializer class uses the name of the field to look up the corresponding field in the object being serialized. If you need to rename this, or there's a reason that mapping won't work for you, the source argument allows you to specify where to look something up. You can specify validators, similar to Django's model validators, that determine whether or not the values in the field being serialized are valid. And then finally, error messages, label, help text, initial, and style are all arguments you can use to specify the presentation. Some of these are specific to certain kinds of renderers. For example, if you were using the HTML renderer, the style argument can pass in CSS information to tell the template how to style the field being rendered. As you've probably surmised, the model serializer that I've been using up until now is built based on top of all these concepts that are already here. The serializer is the beating heart of the DRF. It's all about how you get that payload and how you use it. For more information on how fields work and how to use the arguments that go with them, see the Fields section of the API guide. So I've shown you how to serialize things and how to specify specialty fields. In the next lesson, I'll show you how to do nested Django ORM objects. In the previous lesson, I showed you how to use a serializer with a plain Python object. In this lesson, I'm going to show you how to deal with related objects and nested serialization. The DRF provides ways to serialize related objects in your ORM. Objects that refer to each other by foreign keys can be identified by an ID. You can also nest serialization by having related objects contained within one another. This time around, I'm going to continue using the Vehicles app from the previous lesson. You can follow along with the new models, serializers, views, and URLs files as shown. If you desire, you can create an admin.py file to go along with the models that are there, or use the one in the supplementary materials. Don't forget to run make migrations and migrate as necessary to get your models into the database. And of course, you'll want some data to play with. You can either use the admin or the load data command with one of the fixtures in the supplemental materials. Like in the previous lesson, I'm going to use the models directory and create a file called vehicles inside of it. The vehicles models file contains two Django definitions, one for a vehicle that has a single field name, and one for a part that is related to the vehicle. Each part has a name and a make, and has a foreign key onto the vehicle, so there will be multiple parts in the vehicle. Because I'm using the models directory, I need to update the dunder init file in order to import the vehicle and part so that Python can find these objects. And here's the serializers file. First off, I want to serialize the vehicle. Except for line 18, everything here is what you've seen before. The vehicle serializer inherits from the model serializer. On line 21, you indicate that this is serializing a vehicle object. On line 22, you list those fields that you're interested in. Line 18 is what's different here. I want to nest the part objects inside of the vehicle object, and in order to do that, I'm going to add a new field called the part serializer. Because vehicles are related to parts through a part set, the field name here is part set. This allows REST to automatically run the query that relates the vehicle to the part. Because there could be multiple parts for each vehicle, I'm setting many to true, and in this case, I'm going to set read-only to true as well. The reason you do this is so that if you create a new vehicle, you don't have to specify the parts that go with it. You can just create the vehicle on its own. You can decide for yourself, based on your construction, whether you want to create things like parts separately from the vehicles or do it with a post containing a nested object. The part serializer is similar to what you've seen before. It's based on model serializer, the meta information points it at the Django part module, and the fields listing lists those fields that are going to be included in the part. Additionally, I've added another field here, which is a custom field called serial number field. The serial number field is going to create a custom serial number based on other attributes of the part. Notice that I'm using the source argument for the serial number field. Normally, the DRF looks for the name of the field and uses that to look up the related value inside of the object. The part object has no field named serial number, so the DRF has no way of looking it up. The argument to source maps this lookup. If I wanted to point this at an existing field inside of the part, I could set the value of source to that field. By setting it to asterisk, it tells the DRF to just use the field serializer and set the value to whatever the custom field returns. And finally, to tie it all together, here's the serial number field. This is a custom field that inherits from the serializer's field object and implements the toRepresentation method. When called, the representation takes a value of the thing being serialized, which in this case will be the parent, the part, and then lines 7 and 8 take information of that part and return a string, which in this case is based on part of the make field and the ID of the part. Each part that is serialized will include a serial number field. Each of those fields will call toRepresentation. The make and the ID of the part will be combined into a serial number and returned into the serialized object. Now to create some views for the vehicle and part objects. Like before, I'm creating the vehicles.py file inside of the views directory. Line 12 declares the vehicle view set. Line 8 declares the part view set. Both of these specify the serializer that they're associated with, and the only thing I've done a little different here is shown you a shortcut for creating your query set. Line 15 and 16 you've seen before, which is implementing the getQuerySet method of the vehicle view set. It returns all vehicles. Alternatively, you can do the same thing by setting the querySet attribute like I've done in line 10. If your query set is simple, like all objects, the querySet attribute is the better way to do this. If determining your query set is more complicated, like I showed you when filtering the restricted values of books with Indie, then you'll need to use the getQuerySet method instead. Here's the vehicle's URLs file. I'm creating a new router, registering the vehicle view set and the part view set, and then including that in line 12 in my URLs path. Here I am in the browser. I'm going to visit the vehicle's URL. This time I've done something that I haven't done in a while. I'm visiting the vehicle's base URL. Because the router has registered multiple URLs inside of it, when you hit the base URL, the router shows you all of the possible children. This is a convenient way of getting meta information about what your interface provides. Unfortunately, it only works with the router, so the list tools method that I created in the previous lesson doesn't show up here. It's still there, it just doesn't show up in this listing. But for those things that are created with a router, you can do this automatically. This in and of itself is an argument for always using view sets and using your router so that you can take advantage of this meta information. I'm going to click on the parts listing, and here you have the data that I loaded before, 2 parts. If you were paying close attention when I showed you the serializers, you would have seen that I didn't include the ID field this time. I include URL. What's URL? URL is a special DRF field that returns the URL that specifies the object. This is actually a better alternative to using the ID. If you have queried this and you have the URL available, you can use that URL to do patches or puts or deletes afterwards. This means you don't have to hard code the URLs for your objects inside of your application. This is definitely a better way to go. There are a couple situations here which you have to do some extra work to get this URL, but in the vanilla mechanism that I've just shown you here, it more or less comes for free. I'll show you the exceptions in the next lesson. Because I'm in the web browser, I can just click straight on one of these URLs, and now I can see the detail information for the part that is in the database. I'm going to go back out to the API route, and now I'm going to click on the vehicles URL. Let me just scroll down here a little bit so you can see all of this. The payload for the vehicles URL contains one vehicle, which is the U26 Werfler, and that vehicle contains a part set. The part set is an array containing all of the parts that are associated with that vehicle. This is nested serialization. This is another good reason to use the URLs when you're referencing these objects. Now you've got both the vehicle and the part information available to you in the payload. If you want to change the vehicle, you can use the vehicle's URL, and if you want to change the part, you can use the part's URL. That's how you do nested serialization. In the next lesson, I'm going to dig more into views and view sets and how you can specify more actions over and above the standard HTTP methods. In the previous lesson, I showed you nested serialization. In this lesson, I'm going to show you more about view sets and how to do custom actions. A common pattern in the REST world is to declare an API that includes multiple objects. Up until now, the view sets and the routers you've seen have been object-specific. If you were going to be creating a single-page web application, you might want one REST call that includes all of the objects that you want back. So it would contain a dictionary, and the dictionary would then have keys for each type of object that's coming back in your page. The view sets methods that I've shown you up until now have been object-specific, so that technique won't work in this case. Instead, I'm going to start by showing you how to declare a view and nest those multiple serializers inside of it. New lesson, new app. This time I'm going to create a new app called API. As always, with a new app, you need to install it in the installed apps listing, add the path for the app into the URLs file, and just to throw you a curveball this time, I'm going to add a little wrinkle. It's a good idea to include a version number in your API path. This allows you to do backwardly incompatible changes with your API by declaring a new version number while maintaining backward compatibility while someone hits the old URLs. An easy way of doing this is inside of the path declaration inside of your URLs file. I'll show you what I mean in a moment. As before, if you're coding along with me, the changes to the views and URLs files will need to be done in conjunction. For the moment, I'm going to be using the data that's already in the database, so you shouldn't need to do any migrations this time. Here's the new view that I'm going to include inside of my API app. Let me just scroll down. The view starts on line 12 with the API view decorator indicating that this is going to be a get view. This view is going to include two different types of information, both the doctors in the person objects and the vehicles. For a little variety, this time I'm changing the query set that's being serialized to be just the doctors, so I'm filtering on anyone with the title doctor. And one other complication arises here as well. I hinted at this in the previous lesson. You may recall that the vehicle serializer uses the URL field. In order to properly populate the URL field, the serializer needs to be aware of the request. When you use a view set, the view set does this automatically for you. Because I'm not using a view set here, I need to pass extra information into the vehicle serializer so that it can see the request object. This is done through the context parameter. The context parameter is similar to the context parameter that you would use in a Django template. It's a dictionary containing, in this case, just the request field. So the serializer includes the vehicles being serialized, because it's multiple vehicles, many equals true, as well as the context that includes the request object. The serializer then uses the request object out of the context to construct the host name inside of the URL so that you can get a fully qualified URL inside of the serialized payload. On line 23, I'm using the person serializer to serialize the doctor's query set. Notice that what goes in the dictionary is actually the data attribute. So I've shortcut here rather than creating an object called the serializer and then calling data on the object. I'm just doing it directly on the constructor in one line. Then on line 24, I serialize the vehicles like you've seen me do before and return all of this inside of a REST response object. Inside the APIs app, I create an URLs file and I register the listing that I just created. Notice that I've named the path v1 listing. This is me versioning the API. In the future, if I were going to create a new, backwardly incompatible listing, I could continue to use the old code under v1 and create a new path under v2. This allows me to deprecate an old API without removing it yet, maintaining backward compatibility for my users. In a window off screen, I'm running the Django development server, and here I'm going to hit it with curl. Version 1 of the API, piping it through the JSON pretty printer, and there's the results. Let me just scroll this back up so you can see everything. The return is a dictionary containing the field doctors and the field vehicles. The doctors field contains an array with all of the doctors, and the vehicles field contains an array with all of the vehicles. Scrolling back down, as before, the vehicles includes the nested part set inside of it, and notice the URLs being used in both the vehicles and part objects. Because I used a view instead of a view set that time, I'm not able to register the view with a router. As a result, you don't get the meta listing of all of the possible views in the root path. But what if I wanted it? Well, you can do anything with a view set that you could do with a view, so this is possible. Here's a new view set that I've added to the views file. I'm not doing anything here that you haven't seen before, I'm just doing it in a slightly different format. The declaration of the class of the doctor's view set inherits from two classes. The first class is the generic view set. Because this is a view set, that kind of makes sense. The second is a mixin. This mixin indicates which actions, and therefore which HTTP methods, will be supported by this view set. In this particular case, all I'm including is the list. So this view set will only support listing objects. For each mixin that you include, you will have a corresponding method. For the list model mixin, I have the list method. Inside this list method, I'm not doing anything you haven't seen before. I'm serializing the doctors, putting those inside of result, and returning a REST response. So here's the new API's URLs file. Since I'm now using a view set instead of a view, I use the router to register it, and I include all the URLs provided by the router, in this case it will only be one, under the v1 path listing, giving me version numbers for my API. Once again, hitting the dev server with curl, and pretty printing it, and there's the result. I'll miss you, Sir Connery. The DRF provides an entire hierarchy of viewSet classes for your use. There's the base viewSet class, the generic viewSet class that I just showed you, which adds the querySet attribute, the getObject and getQuerySet methods, the model viewSet that you've been using in the lessons up until now, and there's also a read-only model viewSet that is a model viewSet but doesn't allow changes to it. Several lessons ago, when I introduced viewSets, I showed you this base class. It's probably worth reviewing now. The base viewSet declares 6 methods that correspond to the actions that are being performed in REST. List lists objects. Create is for a post, creating an object. Retrieve is to get a specific object. Update and partial update are for updating existing objects, and destroy is for deleting an object. Each of these methods is declared inside of a mixin. It's done this way so you can mix and match the mixins and create a view set with only those methods that you wish to support. The mixins are create, list, retrieve, update, which provides both update and partial update methods, and destroy. Essentially, there's a mixin for each one of those methods I just showed you in the base class. Additionally, if there's something that you want to do that isn't covered by one of those actions, you can declare your own. You do this by adding a method to a viewSet subclass and then decorating it, indicating that it's an action. One of the more common purposes for this is mass operations. REST, by default, doesn't support the change of more than one object at a time. For example, if you wanted to be able to delete multiple objects, you would have to make multiple calls. Instead, you can create an action which is mass delete. Let me show you how to do that right now. Here's my mass delete view set that I'm adding to the views file. First off, I have to inherit from generic view set so that this is a view set. Secondly, this view set is only going to support deleting objects, so I'm going to use the destroy mixin. Inside of the class, I'm creating a method called mass delete, and I tell DRF that I want this to be an action available in the REST API by decorating it with the action decorator. I'm passing two arguments to the decorator. The first is detail equals false. This tells the DRF that the URL to be used with this action does not include an ID. Because I'm going to be deleting multiple objects, I just want a regular URL. I don't want /3 on the end of it. Secondly, I'm passing in a list of the HTTP methods that I'm supporting in this action. In this case, it's only delete. Because I'm deleting more than one thing, I somehow have to get multiple IDs up to the server. There's different ways of handling this. I could use get with query parameters, or in this case what I'm showing you is using a post with a string inside of it that is comma separated. When this action is called, I will process the post field named IDs and split it on any commas inside of it. Each value that is found is assumed to be the ID of an artifact that needs to be deleted. I fetch that artifact and then call the delete method on it. Finally, because there's no payload that I want to return, I just send back an empty response object. And here's the updated URLs file. You'll need to register the mass delete artifacts view set with your router, adding it to the already existing doctor's registration. Let me run a query just to show you what data is available for the artifacts before I delete anything. And there are my two artifacts. And now I will call mass delete. I specify $X delete so that I use the HTTP delete method with curl. And the -d parameter shows the post fields that I'm going to be sending in of 1, 2. Notice that the URL is a little weird that you've got the mass delete twice. This has to do with how the router constructs URL names. It's based on both the class name and the method that is attached to it. There are things you can do to modify this, but you kind of have to jump through hoops. It's easier just to accept it as it is. Finally, to show you that this worked, I'll run the get again. And object 1 and 2 have been deleted, so there's nothing left. Next up, I'm going to leave Fedora behind and show you a new sample application that's almost a single-page application to show you how this works in the real world. In the previous lesson, I showed you how to add actions to view sets. In the next two lessons, I'm going to run through a single-page application and how you could use the DRF to help you build one. Single-page applications have become a popular way of building things on the web, and REST is a common protocol to be used with these SPAs. Single-page applications are split into a front-end and back-end. Django can be used for traditional web or as the back-end for an SPA. Your Python code on the server side includes managing any sort of business logic, and then you can use the Django ORM and database for storage. On the front-end side, there are plenty of frameworks out there to help you build SPAs. Vue, React, and Angular are some of the more popular ones. To demonstrate how the DRF can help you write these kinds of applications, I'm going to show you a small SPA. The S is a bit of a lie. I'm actually going to build 2 pages. The first will be a traditional web one that just lists a series of schedules, and then the second will be a wholly contained timeline editor, which allows you to edit the timelines associated with those schedules. I'm going to be using the Vue.js library to do this. Vue is a model view JavaScript frontend that uses declarative rendering. What that means is you pass it some JSON, and you apply HTML templates, and as the JSON changes, Vue automatically updates the templates. If Vue interests you, you can find out more about it at its homepage here. In addition to Vue, I'm going to use a couple of libraries that I've written myself. They're open source and available on PyPI, so if you find them useful, go for it. The first of the 2 libraries is called Django All. It's kind of a catch-all library for me. It contains a bunch of tiny little pieces of code that I've used over and over again in different Django applications, but none of them were large enough to warrant their own package. One feature in particular that I'm going to use is called a ranked model. The ranked model is an abstract Django model that manages ordering of objects. If you'd like to see the source code for Django All, it's available on GitHub. I'm also happy to take bug fixes and contributions. Feel free to submit a PR. Django All has been tested in production code, but nothing at a huge scale yet, so I don't promise it won't fall over. I can't say the same about the next one. Django Bootstrap Models is a series of modal dialogues in Bootstrap and includes REST-specific dialog boxes. This one's also available up on GitHub, but unlike Django All, this has only ever been used for prototypes. It's probably okay, but caveat emptor. So here are the pieces of the schedule app. On the data side, there's a Django app called Timeline with a models file inside of it. It declares 2 objects for the ORM. The first is a timeline object, which really is just a container for entries in a schedule, and the second is the entry itself. The entry contains a description and a time length. There's another Django app that's responsible for the REST API. Inside of it, you'll see serializers.py containing a serializer for each timeline and entry, a views.py file containing a view set for each timeline and entry, and then additionally another view called changeRank. The entry object inherits from Django All's ranked model class. This is what specifies the order of the entry inside of the timeline. Ranked model has logic inside of it that ensures the ranks are consistent if one of them changes. This logic is done in an overridden save method. Unfortunately, the DRF's update methods don't actually call an object's save, so the side effects that are done as part of ranked model's save method will not get called if you make a change to the rank through the REST API. So as a result, I've written an additional view called changeRank, which specifically calls the entry's save method to ensure that the rank reordering happens properly. Here's how things work when a user hits the application on the browser. First off, you visit the timeline page. That hits a view on the Django side. That's inside of the timeline app in its views file. The view is called Edit Timeline, and it renders a template called Edit Timeline. That template contains HTML as well as the Vue.js components. The Vue.js components initialize, and then as part of the initialization, the Vue component will make a REST call to fetch the timeline that's being edited. That REST call goes to the API on the Django server and hits the timeline view set. The timeline view set serializes the timeline, which then serializes nested entries, and those are returned back to the browser application as JSON. That JSON is then used by Vue.js and its internal templating mechanism to present the actual page. Inside of the client application, there are a few things you can do. The first would be to add a new entry. When that is triggered, Vue.js calls a method on a form. That form is a Bootstrap model form. The method is showCreate. ShowCreate takes a REST API URL, in this case, the one for entries, and some data for the entry that is to be created. The ID of the timeline and the rank are set by default. The ID of the timeline is the parent timeline for this page, and the rank is set by default to one more than the highest ranking item on the page at the moment. A form is displayed. When the user submits the form, the data from the form, as well as the hidden timeline and rank fields, gets sent to the server by showCreate. This is a REST call. That hits API v1 entries, creating the object on the server, which responds back with JSON of the object created, and that's populated inside of Vue.js. A similar process happens when an entry is edited. The same form is used, but this time it calls a method called showPatch. ShowPatch takes two parameters: the URL of the object being edited. This would be the entry object inside of Vue.js that's actually being edited, and its URL attribute, and then the data from the actual entry object. ShowPatch shows the same form, pre-populated with the data from the entry object. The user can then make changes. When they save the form, Bootstrap Modals makes a REST call. That REST call is to the entries object with the given ID, sending up the fields from the form and patching them on the server. The REST call returns the resulting changed data, and Vue.js is populated with the change, and the change is reflected on the screen. The other possibility is one entry is dragged around on the screen, changing its order. This is done through a library called VueDraggable. VueDraggable has a hook on it for the onMove event. The function that is called in the onMove event figures out what entry has been changed and calls through REST the change rank call. This passes in the ID of the entry being changed and the new rank. That calls the specialty view that ensures that entry's save method gets called, which makes sure that all the ranks are set correctly. And in this case, because multiple ranks may change, the change rank view returns all of the entries for the timeline. Vue.js then updates its copy of it based on the JSON returned, and then updates the screen. I hope this gives you a little bit of a glimpse of how these things work, and how you can quickly slap together some items with very little code on the server simply by using something like the REST APIs you've seen in this course. Next up, I'll take what I just showed you in pictures and show it to you in code. Just as a little warning, it'll be both Python and JavaScript to show both parts of the code. Be prepared. In the previous lesson, I showed you an example of an SPA architecture for the sample SCED application. In this lesson, I'm going to dig in deeply and show you some of the code that goes along with it. Even for a relatively small application, there's a fair number of moving parts here. There's HTML, there's Python, there's JavaScript, there's Vue.js specific JavaScript, and Vue.js specific templates. I'm not going to go through all of that. For the most part, I'm going to concentrate on the server-side Python and some of the JavaScript. In particular, I want to highlight the parts where the DRF is interacted with, and then some integral parts of the JavaScript inside of the Vue pieces on the client side. The site you're watching this on, of course, isn't called Real JavaScript, it's called Real Python. So if you're not familiar with JavaScript, this could be a little bit painful. The expectation here isn't for you to understand every little bit and piece, but just to get a high-level view of how the parts fit together. Don't forget, all of this is available inside of the supplementary materials, and you can play with it on your own if it helps you understand. If you're going to run the sample code for yourself, you're going to need a couple things. First off, you'll need to install the dependencies. The dependencies are listed inside of requirements.txt. In order to keep your Python environment clean, it's best practice to use a virtual environment for this. You can install all of the requirements.txt file by using the -r parameter to the pip install command. This will take everything inside of the text file and install all of it. Inside of the sched directory, you'll find a shell script that you can use to create the database, do the migrations, and set everything up. This is a bash shell script. It will only work if you are using some sort of Unix derivative. So if you're on a Mac, on Linux, or you're using the Windows Linux subsystem, then you can use this command as a shortcut. Here's the contents of that script. If you happen to be running on regular Windows and you can't use this script, then type these 6 commands in and you'll be good to go. Actually, you'll only need the last 4, because if you've got a brand new environment, there won't be any PYC files or a SQLite file to get rid of. The first command, wipe migrations, comes out of Django all. It destroys any migration files. I use this command when I'm playing with a brand new project, so that I don't create overly complicated chains of migration history when I don't really care about the migration history because I haven't gone into production yet. So it starts me clean each time. Then make migrations and migrate will set up and run your database, and then load data is used to grab the sample data for the timelines. The first half of this script gets rid of anything that's there already, so if you play around and you want to start from scratch, run the script again. Let me show you what this application looks like in the browser before I show you the code. Off screen, I'm running the Django dev server, and here I'm going to hit the home page of localhost port 8000. Here's the first of my 2 pages of my single page application. This one is a standard Django view that spits out a simple bootstrap listing of the timelines that are in the database. Clicking on Peru takes me into the second page of my single page application. And this one's a little more SPA-ish. This is built with Vue.js. Each row in the schedule corresponds to an item in the database. All of the rows are being sent down via JSON, and then interpreted by Vue.js. I can click the Add button, and get a pop-up for entering new information. This pop-up is one of the Bootstrap modal pop-ups coming from that library that I told you about. The pop-up is REST-aware. This form inherits from a base class that knows how to create things in REST. It uses the names of the fields inside of the form and populates an AJAX call up to the server with a post method. By doing this, I need very little code to be able to create new objects on the server. I just need the form to create them and to make sure that the name attributes of the form are properly set. Submitting the form does a call to the server and updates what's on the screen. Clicking on one of these objects pops up the same form. Now the same form can be used to do an update. The Bootstrap modal library takes care of all of this for you. Clicking the delete button brings up a confirmation dialog. These dialogs are also part of Bootstrap modal. If I click yes, then a JavaScript function is called, calling this REST delete on the object in question. I'll show you the code to that shortly. And finally, this application is drag and drop enabled. The handles on the left-hand side of the screen allow me to change the order of the items. This no longer follows the movie, but you see what I'm talking about. The movement updates the rank of the item affecting the order on the server, and this has to be done with a custom action in order to take advantage of how ranked models work. Here are the models for the application. There's 2 things in the database. One, which is a timeline, which is named and groups a series of entries, and the other is the entries. Line 6 through 10 defines the timeline, and the entry object starts on line 12. Let me just scroll down here for you. The entry has 4 fields. 3 of them are defined here: title, length, and the timeline that's associated with it. And the 4th is hidden in the abstract model called ranked model. The ranked model contains a field called rank. This is an integer that is 1 or more and indicates the order of the entry. Inside of the meta class, I specify the ordering as the rank field to make sure that when these are queried, they come back in rank order. Here's the views file that defines the two pages in my single page application. Line 6 is the home page that lists all of the timelines, and line 14 boots up the single page application part of this single page application. The edit timeline view takes an ID, which is the timeline that is being edited, and then it renders the edit timeline.html file. That file, amongst other things, contains the information that Vue.js needs to render the page. Up until now, I've been showing you the core app, which is for the timelines. I've also created another app called the API. I'm grouping all of the things that will be available through REST inside of the Django API app. That includes the serializers.py file. Inside of the serializers file, I have two serializers, one for the timelines and one for the entries. The timeline serializer contains the entries within it, so I'm nesting entry objects inside of the timeline. Here's another use of the source attribute. The name entry set might be a little confusing inside of the HTML or for anyone who isn't familiar with Django. So I've changed the serializer to call the entries entries. The entry serializer then has the source parameter of entry set, telling the DRF that the entries field should be populated based on entry set of the timeline. Because there are multiple entries, many is set to true, and so that I can create a timeline without specifying and serializing entries to go with it, I've set read-only equal to true as well. The entry itself contains the ID and the URL of the entry, the title, length, and rank of the entry. It also contains the timeline field. This will be the ID of the foreign key of the timeline object. This is necessary because you can't have an entry without it pointing at a timeline. So when you go to create a new entry, you're going to need that timeline ID. Inside of the API views file, I define the view sets for the DRF views that I'm going to use in the application. The first two items here are the vanilla view sets for the timeline and the entry. I've specified their corresponding serializer classes and the corresponding query sets. Let me just scroll down. The abstract ranked model class has logic inside of it that ensures that the ranks stay in order. The logic of all of this is done inside of an overridden save method. The DRF does not call the save method on an object. It directly updates the database. Any logic in an overridden save is not going to get executed. As a result, I've defined a new view here that is specific to changing the rank. I'm not going to use the built-in update methods of the DRF. I'm going to update it myself manually to ensure that the entry's save method gets called. Except for this being a special case as to why I'm doing it, the rest of it is a view like you've seen before. I'm using the API view decorator to indicate that this is a get. This is a little hackish. To be more technically correct, I probably should have made this a put or a patch because I am editing an entry. But the URL that I'm going to be using for change rank will include the ID of the entry and its new rank. Because I'm doing this inside of the URL, I'm sticking with a get. This is one of those many cases where REST is kind of a suggestion rather than a rule. Using the entry ID, I get the object. I change the rank to the new rank provided and call the overridden save. I then requery all of the entries that are associated with this timeline and serialize them, sending them back down. This means when a move has been executed, the Vue application can get all the data at once as to what the new ranks are of all the entries that were affected. This is part of the edit timelines HTML file. The script body block is where all of the JavaScript pieces get set up. The key to interfacing with the DRF is passing a URL that specifies the timeline REST API action point to the Vue code. I've done this through the URL tag when this page gets rendered. The tag returns the timeline point for the REST view and sets that URL inside of the JavaScript global variable fetch URL. The Vue.js application will then use this to fetch the payload and populate the page. The remainder of this block is the loading of a variety of JavaScript files, including those to do the Bootstrap modals dialogues, a utilities function that deals with CSRF prevention, the actual Vue.js application inside of timelines.js, and a third-party library that allows me to do drag and drop with Vue.js. This is the timelines.js file. This is where the master object for Vue.js is created. That's on line 4, and it's put in a variable called VM. You'll see the use of that variable throughout this file. In lines 8 through 11, I create the data for the Vue.js object. Has loaded is used to indicate whether or not the screen should be rendered yet. Timeline ID, name, and entries are all the JSON that come from the server. Timeline ID and name being from the timeline object, and entries being the array of JSON that specify the entries on the display. Django has a whole bunch of security mechanisms built in, one of which is to prevent problems with form posts. This is done through the CSRF token. The AJAX setup and getCookie methods come out of the utilities.js file and are used to make sure that a post can happen. All Django posts must include a CSRF token, so this little bit of code gets that token in the right place. Once everything's loaded on the page, the last call here is to refresh Vue. This method is what actually does the REST call. Inside of refresh Vue, I use jQuery's getJSON method, passing in that global fetch URL variable. GetJSON takes a response function, and inside the body of that response function, I'm setting up the Vue.js data attributes. Timeline ID and name both come out of the response field from the timeline object, and entries is copied from the array of entries. Once those three values have been put inside of the Vue.js object, I set hasLoaded to true to get the screen to render. The Vue.js template that is rendered included the add button. There's a hook on the add button that says when the button is pushed, call the method addEntry. That's defined here on line 14. Inside of the addEntry, I create a dictionary that contains the ID of the timeline object for the entry that's being created, and a rank. The rank is set to be one more than the last rank currently in the listing. The Bootstrap modals library has a way of declaring forms and using REST methods to update objects that are associated with them. In line 22, I'm using the change form, which you saw that was popped up when you hit the add button, and I'm calling the showCreate method on this form. ShowCreate knows how to talk to REST using a URL, doing a post, creating a new object. The first parameter to this method is the URL of the post, API v1 entries, because I'm creating a new entry. The second parameter is the default data for the dialog box that's being popped up. The dialog has two hidden fields, which are the timeline and the rank, and then the two fields that you saw, the title and the length. That populates the dialog box. When the user hits save, the server is contacted by the Bootstrap modal library, the REST post is done, the object is created, and then the third parameter of showCreate is a callback. The response contains the newly created object. vm.entries.splice is a way of taking that response object and gluing the result into the entries listing on the Vue.js object. This adds the newly created entry to the list on the screen. Edit entry works in a similar fashion. Once again using the same form, this time calling a method called showPatch. ShowPatch takes the URL of the entry that was passed down as included as part of the JSON payload, the entry object itself, which it uses to populate the form, and then when the user hits OK in the dialog box, a patch is issued to the server. The REST code is triggered, the entry is updated. The third parameter to show patch is once again a callback. Once the entry has been patched, the server responds with the updated entry. The Vue.js VM object has the entries array spliced, replacing the old entry with the new one that was just edited. You saw on the screen that I'm using a third-party library for Vue.js called Draggable. The Draggable library comes with its own tag, and inside of that tag I have specified that when a drag action completes, that this method entryMoved gets called. You'll recall that I don't want to just call patch here on the rank number because I need the object's save method to get called on the server. So I'm calling a specific custom REST action instead. I do that by using jQuery's getJSON. The URL is the change rank URL that I showed you earlier, complete with the ID of the entry that's being changed and its new rank. And getJSON has a callback. And I take all of the entries that come back from the change rank and replace the client-side copy. Similar to the add button, each delete button is also wired to a function. That's this delete entry method. Inside of that, I'm using another dialog box out of the Bootstrap modals library called confirm. Confirm shows a title and whatever text you give it and presents a yes and no button. Then it has a callback mechanism that checks whether or not the user hit yes or no. On line 52, I look for a negative result and do nothing. The REST call happens on line 56. If you get here, then the person hit yes. It takes the entry object on the client side, grabs the URL, and does a straightforward AJAX call using HTTP delete on that URL. The object has now been deleted on the server side. There were a lot of moving pieces in that. I hope it wasn't overwhelming. My intent was just to give you a flavor of how the REST pieces can be used inside of a single-page application. If you're truly interested in how all those pieces work, you'll probably want to dig into the sample code and walk through it yourself. Next up, the last lesson, summary of everything you've learned. In the previous lesson, I showed you a sample single-page application. In this final lesson, I'll summarize what you've learned. REST is a loosely defined protocol that allows you to list, create, update, patch, and delete data on your server. It uses existing HTTP methods and URLs to perform the actions. The Django REST framework, or DRF, works in conjunction with Django to perform REST activities on top of Django model objects and views. Inside DRF, the serializers are responsible for turning your data into payloads and taking payloads and turning them into your data. The model serializer maps Django ORM objects. This means it takes very little code to convert something you've already got into a payload. Objects with relationships on the server side can be serialized together and nested into parent objects. Although the most common use of serialization is to serialize Django ORM objects, DRF serializers are able to serialize generic Python classes. You can pretty much serialize or deserialize almost anything that you want. You implement a REST endpoint with a view on the Django side. The DRF provides decorators to wrap your views and REST response objects that know how to work with the serializers. In addition to the views, the DRF provides a series of classes called view sets. These classes group together multiple HTTP methods or REST actions and manage them together. This is particularly useful when you're serializing a Django ORM object. You can create a view set that has all of the REST action points for that ORM object in just a few lines of code. You can create a DRF router object to register one or more view sets, and it will automatically map that view set to the necessary URL patterns. You can manage who sees what data and what they're allowed to do with it by specifying permissions and query sets associated with a view set. You can also add custom actions to a view set in order to augment the base REST calls. The DRF response object takes information out of the serializer and turns it into a payload. It does this through a renderer. DRF supports several different ways of rendering your data. By default, it gives both a JSON and a web-based interface for your payloads. You can also control which renderer is being used and how things are rendered through changing settings or decorators of your views. For further reading and minutiae on the DRF, go to the Django REST Framework website. The website also maintains a huge list of third-party packages that may already implement that corner case that you've been worried about. Take a look at this URL for more information. I hope this course has been valuable to you. Thanks for your attention.